Okay, here we're finding the limit. The limit you should be familiar with is this one. The limit of this is 1. For this to be true, when there's little variations, these two parts must be identical. In this case, they are identical, so the limit is 1. So what do you do if they're not identical? If I have something like this, and there is no 4, you can put a 4 down there. And what you do, you put a 4 down there, then you compensate for that 4 by putting a 4 up there. But it's this part that goes to 1. So this then will be the same as limit as x goes to 0. Oops. Put the 4, this 4, up front, because that's not a variable. And you can take this limit. So now it becomes 4 times 1, or 4. Or what if we have something that looks like this? Sine of x over 4x. Well, you basically do the same thing. The thing that what we want is for these parts to be identical, so we can take that 4 out, and it becomes 1/4 outside. So again, this has a limit of 1, so it's 1/4. That's it. Let's see the next problem if I can find it. Alright, in this problem we want to factor. That's going to be x plus 2, x minus 1. It's going to be x plus 3, x minus 1. So we're going to cancel out the x minus 1. So as it turns out, if we plug in the 1, we get 0 over 0. Remember, the goal for any kind of limit is to be able to plug it in. And since plugging it in gives us an indeterminate form, a form 0 over 0, right? If we plug in 1, that turns into 0. The numerator turns into 0. The denominator turns into 0. So it's no good. But here, we can cancel the x minus 1. And remember, when you take the limit, they're equal to each other as long as they're same, except at that value, that where you're going to. Alright, so now I can just plug it in. So that's going to be 3/4. If I plug it in, 1 plus 2 is 3. 1 plus 3 is 4. That's number 2. Let's see if we can do number 3. I know, sorry, that's kind of disgusting. Okay, let's do this one. This is a one-sided limit. We're going to approach 1 from the right. So that's like 1.1, 1.01. Let's see if we can factor this first. Numerator doesn't seem to have a problem. 1 plus 2 is 3. The denominator is approaching 0. So we have a numerator approaching 3 and the denominator approaching 0. So that's a problem. Okay, that's a problem. I'm going to go ahead and factor it. Even though nothing's going to cancel, it's going to be x plus 3, x minus 1. Alright, now why did I do that? So technically the limit does not exist, but we want to be more descriptive than that. We want to say something like positive or negative infinity if we can help it. Looking at this, whenever you have a fraction and the numerator is approaching as a constant and the denominator is approaching 0, this is going to approach either a positive or negative infinity. So the question is it positive or negative? So if we look at this, we're approaching 1, so it's like 1.1. Think of numbers like 1.1. So 1.1 will make the numerator positive, x plus 3 positive, and x minus 1 positive. Like 1.1 minus 1 is 0.1. So it's positive 0.1. So this is going to approach positive infinity. Okay. Technically it doesn't exist, but we want to be more descriptive, so we say positive infinity. And that's enough for that video.